Then we'll understand the various applications of the cloud computing. And lastly, we will see what is intranet and the cloud. So at the end of this session, you will be getting the overview of the cloud computing. So let's get started. Here you can see the diagram of the cloud. You generally see the cloud in the sky. And why this cloud computing is being given to this technology is due to the use of the symbol. You can see for showing the internet, we are using the symbol of the cloud. Whenever we draw a network diagram, we can see the internet is being shown with the cloud symbol. And we know over the cloud, the data is moving from the servers to the client. Yes. Now understand the relation of this internet and the cloud computing with the help of the definition of the cloud. So the basic definition of the cloud is it is a construct that allows you to access the applications that actually reside at a location other than your computer or the other internet connected device. Most often, this will be a distant data center. So here we are accessing the applications which are not located at our center. What we are doing, we are using the simple browser and accessing the applications over the internet. So simply putting, this cloud computing provides a variety of the computing resources from the servers and the storage to enterprise applications such as email, security, backup, RDR, voice, all delivered over the internet. The cloud delivers a hosting environment that is immediate, flexible, scalable, secure, and available, while saving the corporations money, time, and the resources. So whatever the services we are using over the cloud computing are over the internet. So you can understand the relation between the diagram that I have shown you in the previous slide, in which we have shown the internet with the help of the cloud symbol. And we are giving the name to this technology as the cloud computing because everything happens over the internet. Yes. How it works. So here you can see the cloud is being shown. That is, it is called as internet. And there are 3 devices connected to the internet. Or we can say it is a cloud computing. So you can see the data being updated by one of the device is being sent over the cloud computing environment, and immediately it is being reflected to the other 2 devices as well. That means if we are using the cloud computing, we get the synchronized data to all the devices which are connected to the cloud computing environment, which are using the same services. So that's how the cloud computing works. Now understand what works. So here you can see the cloud computing. This side we have the client side, and this is the service provider side. So if you are looking at the client side, there is no hardware, there are no servers. They have the thin clients associated with them, or they may have a full simple machine with CPU. Here we are showing the thin clients without the CPU, and there is one central machine which have the CPU, works as a normal server, and that is connected to the internet. And these thin clients are connected to this machine. So here you can see your company does not pay for the hardware and the maintenance. This do not have any type of servers. This do not have any type of the applications with it. All the applications, all the hardwares are purchased and maintained by the service provider. And how the client uses those applications and those hardware, the clients are using all the services, all the hardware over the internet as a service. Yes. So with the cloud computing, other companies host your applications. Now understand what do not work in the cloud computing. So the weak links is a thing which do not work for the cloud computing. We know the clients must be connected to the internet, and we know the service provider must be connected to the internet. They may have the different service providers. So the link between the clients and its service provider should be strong enough to get the access of all services provided by the service provider. If this link is weak, then we will be unable to access the services which are offered by this service provider. And if this link is good enough, but the service provider have the weak internet link, then also the client will not be able to get access to the services which are offered by the client service provider, cloud service provider. So here the difficulty is the internet connectivity. If we have the weak links, we will be unable to use the services of the cloud computing. Now look at the components of the cloud computing. So basically there are three components. One is the client computers, second is distributed server, and third one is the data center. Let us see one by one in detail. First component is the clients. So clients are the users of the services. There are three categories of the clients. First is the mobile. It includes the PDA or smartphones. Second type of the clients are the thin clients. These are the computers that do not have the hard drives, but rather let the servers do all the work. And third type of the category here is a thick client, in which it is the computer having its hard drive. That is a regular machine with the CPU. How the thin client looks like. You can see there is no CPU, there is no hard drive here. So it has only monitor, it has a keyboard, and it has a mouse. It is connected to one box, which is connected to a central server. So there are many such a thin clients which are connected to a single server. So all the things are being done at the server side. This only is being used for browsing purpose. And what we are doing in the cloud computing, we need only the browser and the internet connectivity, which we can get with these three devices only. Nowadays, the thin clients are becoming an increasingly popular solution because of their price and effect on the environment. So what are the benefits of using the thin clients? It lowers the hardware cost, as there are no CPUs involved, multiple CPUs involved. It lowers the IT cost. It provides the security to your devices. It also provides the data security to the devices. It consumes the less power, and it is easy of the repair or replacement, because everything is being connected to a single server. So it is easy to replace at a single place. And it has a less noise. Second component is the data center. So what is the data center? Data center is a collection of the servers where the applications to which you subscribe is housed. It could be a large room in the basement of your building, or it can be a room full of the servers on the other side of the world that you access via the internet. So a growing trend in the IT world is virtualizing the servers. That is, software can be installed, allowing the multiple instances of the virtual servers to be used. How the data center look like? You can see it is having the stack of the servers, it is having the stack of the storages, all the switches, and all the devices are connected with each other. And the room is being completely cooled with the help of the ACs. The third component is the distributed servers. You can see in the diagram, the servers are distributed geographically. These are at the separate locations, and all the servers are synchronized together so that all the users of those servers get the synchronized data. So whatever the work done by these clients are being synchronized with these three servers, so that the other clients, or say these clients, get the same data, updated data. Now look at the applications of the cloud computing. First application is the storage. So the cloud computing can be simply used for the storage. The benefits are in the line with the general benefits of the cloud computing. If you lease the storage space from the vendor, you are not responsible to buy the equipment. Pay to run it and pay to cool it. That's all the vendor will do. But there are different options when it comes down to the cloud storage. Second application is the database. So database are the repositories for the information with the links within the information that help make the data searchable. So distributed databases like Amazon SimpleDB spread information among the physically dispersed hardware, but to the client, the information seems to be located in one place. The advantages of such databases includes improved availability. What do I mean improved availability? If there is a fault in one database system, it will only affect one fragment of the information, not the entire database. Second advantage is improved performance. Here, the data is located near to the site with the greatest demand, and the database systems are parallelized, which allows the load to be balanced among the servers. Third advantage is price. It is less expensive to create a network of the smaller computers with the power of one large one. Fourth advantage is flexibility. The systems can be changed and modified without harm to the entire database. Likewise, we have the advantages. We may also have the disadvantages. So what are the disadvantages? First is the complexity. So database administrators have extra work to do to maintain the system. Second is the labor cost. With that added complexity comes the need for the more workers on the payroll. Third is the security. The database fragments must be secured, and so must the sites housing the fragments. Fourth disadvantage is integrity. It may be difficult to maintain the integrity of the database if it is too complex or changes too quickly. And last disadvantage is standards. There are currently no standards to convert the centralized database into a cloud solution. Next application is the database services, that is the DAAS. So another as a service offering that is becoming prevalent in the cloud. It is a database as a service. So the idea behind this DAS is to avoid the complexity and the cost of running your own database. There are some benefits of using this database as a service. The first is the ease of the use. There are no servers to provision and no redundant skills to worry about. You don't have to worry about buying, installing, and maintaining the hardware for the database. Second is the power. The database isn't housed locally, but that does not mean that it is not functional and effective. Depending on your vendor, you can get the custom data validation to ensure the accurate information. You can create and manage the database with this. Next benefit is the integration. The database can be integrated with your other services to provide the more value and the power. For instance, you can tie it in with calendars, emails, and people to make your work more powerful. And last advantage is management. Because large databases benefit from the constant pruning and optimization, typically there are expensive resources dedicated to this task. With some DAS offering, this management can be provided as a part of the service for much less expense. The provider will often use the offshore labor pools to take advantage of the lower labor cost there. So it's possible that you are using the service as in Chicago, the physical servers in Washington state, and the database administrator is in the Philippines. So there are some DBMS, that is databases, that is the MS SQL. And another one database we can use is the Oracle. There are many more, but these are the prominent ones. And last topic we are looking at is the intranets and the cloud. So by setting up a thin clients to run the applications and the services on the local server rather than on their desktops, you ease the cost of the deployment and the maintenance, as well as reducing the power cost. There are two main components in the client server computing. You can see here in the diagram, we are using here the thin clients. And they are connected with the servers over the internet. The servers house the applications your organizations need to run, and thin clients which do not have the hard drives display the results. So in this way, we can see the basics of the cloud computing. So thank you. See that when we should not use the cloud computing. Then we look at the various scenarios provided by the cloud computing. Then we'll look at the benefits and the limitations of the cloud computing. And we'll look at some of the security concerns. So at the end of this session, you can decide whether your organization can go for the cloud services or not. That's why the title is named as Your Organization and Cloud Computing. Likewise, the cloud computing is not a one-size-fits-for-all affairs. Just as the hardware and software configuration you use in your organization is different from that the company down in the street, your cloud computing needs will be the different as well. So here we will understand how your organization can best use the cloud computing and which solutions might be most appropriate for your needs. And while we talk about the cloud computing is good for, we also talk about the cloud computing limitations. That is, the cloud computing is not perfect, and there are times you should not turn to it. So we'll examine those cases as well. So let's get started. The first thing we'll look at is when you can use the cloud computing. So whether or not you should use the cloud computing depends on the number of factors, including the cost oblique benefit ratio. The organization has to check the cost of the cloud versus the benefit. Second is the speed of the delivery of the cloud computing. Third factor, they have to look at how much the capacity you will use. Fourth factor has to be taken into consideration is whether your organization is regulated or not. And fifth factor is your organization's corporate and the IT structure. So by considering these factors, one should use the cloud computing. Now look at the various scenarios. There are different major implementations of the cloud computing. How organizations are using the cloud computing is quite different at a granular level, but the uses generally fall into one of these solutions. The first is the compute clouds, second is the cloud storage, and third is the cloud applications. Now we'll move each one in the detail. First is the compute clouds. The compute clouds allow access to the inexpensive, highly scalable, and on-demand computing resources that run the code that they are given. So there are three examples given of the compute clouds. First is the Google's App Engine, here you can see. Second is Amazon's EC2. And third is the Berkeley's Open Infrastructure for the Network Computing, that is the BOINC. These compute clouds are the most flexible in their offerings and can be used for the sundry purposes. It simply depends on the application the user wants to access. Next scenario is a compute storage. So on the first cloud offering, one of the first cloud storage cloud offering was a cloud storage, and it remains a popular solution. Cloud storage is a big word. There are already in excess of the 100 vendors offering cloud storage. This is an ideal solution if you want to maintain the files offsite. Third scenario is the cloud applications. The cloud applications differ from the compute clouds in that they utilize the software applications that rely on the cloud infrastructure. Cloud applications are the versions of the software as a service and include such things as web applications that are delivered to the users via a browser or application like Microsoft Online Services. These applications offload hosting and IT management to the cloud. The cloud applications often eliminate the need to install and run the applications on the customer's own computer, thus elevating the burden of the software maintenance, ongoing operation, and support. Some cloud applications include peer-to-peer computing like BigTorrent and the Skype. Second is the web applications like MySpace or YouTube. Third is the SaaS like Google Apps. And fourth is the software plus services like Microsoft Online Services. Next topic we will look at when you should not use the cloud computing. So we had been remiss if we just did the cloud computing cheerleader things, suggesting you could use it for absolutely everything. The fact of the matter is there are plenty of the cases where cloud computing may not be appropriate for any reason ranging from the cost to the hardware requirements to simply not needing it. So let's see the first factor here is the minding the details. If you want to use the cloud computing and post-data data covered by say Health Insurance Portability and Accounting Act, that's a HIPAA on it, you are out of luck. Well, let's rephrase that. If you want to put the HIPAA data on the cloud, you should not. That's the sensitive healthcare information, and the fact that the HIPAA data could commingle on the server with another organization's data will likely get the attention of the observant HIPAA auditor. So this is how the details are minded by the organizations. Next, the legislative issues. An issue of the more concern for the sensitive or say private data is that there are laws and the policy that allows the government freer access to data on the cloud that on a private server. For example, the Stored Communications Act allows the FBI access to the data without getting a warrant or the owner's consent. Third is the geopolitical concerns. You may simply be illegal to post your information on a cloud if you are in Canada, for instance, if you say, and you want to post your data on an American cloud, then you are really out of luck. Next is the hardware dependencies. If you have an application that requires a specific hardware, chips or drives, a cloud solution might not be a good fit for you. First, if you have special hardware needs, the chances are lower that the service provider will have the precise hardware you need. You can significantly narrow your options when it comes to shopping around and finding the good deal. But let's say the planets are in the perfect alignment. The provider you like has the hardware you need, and before you long, you are both humming away. This is all blissful now. But if the provider ever changes chipsets or other critical hardware, you might be out of luck. Next is the server control. If your application demands a complete control over everything that is running, a cloud solution may not be right for you. If you need detailed control over the amount of the memory, CPU, hard drive specifications, or interfaces, then the cloud is not an appropriate match for your application. After all, these are all things managed by the service providers. Next factor is the cost. One of the big draws of the cloud computing is the cost. That is, it tends to be less expensive to run an application on the cloud than to invest in infrastructure, buy the application outright, and then manage it day to day. However, over time, it may be cost more to pay a cloud subscription than to have simply brought the servers yourself. So it is an important factor in everything from the facilities, staff, software, and hardware. The cost and the way clouds operate are moving targets. Some have suggested that the cloud might bring servers into the client's data center. Another school of the thought is the concept called as a cloud bursting. Next factor is the lack of need. If we can say anyone with a grandfather has heard the phrase, if it aren't broke, don't fix it. And the grandpa is right. If your current solution is getting the job done, why thinking for the other? Now, there are certainly cases where the cloud computing is advantageous for you. And in those cases, by all means, use it. However, if you are just moving applications to the cloud for the fashion of it, take a look at some old pictures of fashionable people. You'll realize that those polyester leisure suits and the mulets may have been fashionable in their days, but not so much now. Next factor is integration with the existing application. The fact of the matter is that if you have two applications that need to be integrated, it's best for one not to be located on site and second on the cloud. It creates a problem with the security, speed, and the reliability. For instance, if you have two databases, one with the sensitive data housed locally and one with the non-sensitive data on a cloud, the chances that the sensitive data will find its way to the cloud are very good. Also, if you're trying to run a high-speed application in the house and you rely on the data from the cloud, the applications will only run as fast as the cloud will allow. This also leads the questionable reliability. Will data will be compromised or damaged from all the flying around it has to do. Next factor is the latency concerns. Since your data and applications are located on the series of the servers, which are geographically disparate locations from your own site, it is going to take some time for your data to reach you. This is not an issue of the hours or delays or even minutes, but if you require the data instantaneously, the cloud might not be a best option. And last is the throughput demands. Since the cloud computing is generally built in a utility format, you pay for what you use. That's great and it seems fair until you deploy the applications that use a lot of throughput and cost starts to rise. For instance, if you are streaming high definition video or 100 sources, your cost is going to spike sharply. So these are the factors where you should not use the cloud computing. Now look at the benefits. First benefit is the scalability. If you are using the cloud computing, it provides you the scalability facility. What do I mean scalability? That means we can scale in or scale out our resources. If you are having the more load on our servers, we can dynamically increase the resources. And whenever there is a less load on the servers, we can just skip or we do not utilize the resources of the cloud computing. So that saves our cost. We do not need to buy the extra hardware whenever required, or we do not have to scrap the hardware when it is not being used. Second benefit is simplicity. Again, not having to buy and configure the new equipment allows you and your IT staff to get right to your business. The cloud solution makes it possible to get your application started immediately, and it costs a fraction of what it could cost to implement an on-site solution. Next benefit is knowledgeable vendors. Typically, when a new technology becomes popular, there are plenty of vendors who pop up to offer their versions of that technology. This is not always good because of a lot of those vendors tend to offer less than useful technology. By contrast, the first comers to the cloud computing partly are actually very reputed companies. Companies like Amazon, Google, Microsoft, IBM, and the Yahoo have been good vendors because they have offered reliable service, plenty of capacity, and you get some brand familiarity with these well-known names. Next benefit is more internal resources. By shifting your non-mission critical data needs to the third party, your IT department is freed up to work on the important business related tasks. So you don't have to add more manpower and training that stem from having to deal with these low-level tasks. Next benefit is the security. There are plenty of security risks when using the cloud vendor, but reputed companies strive to keep you safe and secure. Next, as there are benefits, there are some limitations as well. So there are other cases when your cloud computing is not the best solution for your computing needs. In this section, we'll look at why certain applications are not the best to be deployed on the cloud. We don't mean to make these cases sound like deal breakers, but you should be aware of some of the limitations. If you can work around them, that's great. But you should be aware of the issues before getting in too deep. So first limitation here, you can see your sensitive information. You know? We are more concerned about storing our data over the cloud, and we are sometimes storing our sensitive information, but it can't be understated. Once the data leaves your hands, that lands in the lap of the service provider. You have lost the layer of control. So what's the worry? So we'll have some example over here. So let's have some financial planner is using the Google spreadsheet to maintain the list of the employee social security number. Now, the financial company here isn't the only one who should protect the data from the hackers and the internal data breaches. In technical sense, it also Google's responsibility, or it will become a problem of the Google. However, what the Google will do now, Google may absolve them itself of the responsibility in its agreement with you. So it's no less complicated task to sort out how sensitive information is genuinely secured. Another, a white door is open for the government investigators to subpoena that information. Also, the less scrupulous service providers might even share their data with the marketing firm. How to protect your data? So the way to protect your data is to use the encryption technology. So while sending your data to over the cloud, we need to encrypt the data. So we can make the encryption to the data and then we'll put it over the service provider. That we can do. Now we'll look at some of the security concerns. So with so many other technical choices, security is a two-sided coin in the world of the cloud computing. There are pros and there are cons. So in this section, let's examine the security in the cloud and talk about what's good and where you need to take the extra care. So IDC conducted a survey of the 244 IT executives about the cloud services. Now you can see the figure here, which shows the security led the pack of the cloud concerns with the 74.5%, 74.6% here. So in order to be successful, vendors will have to take the data like this into the consideration as they offer up their clouds. There are various things here. You can say the performance, the availability, hard to integrate with the in-house IT, not enough ability to customize, and so on. So are they doing enough to secure it, the service providers? Before signing on with the reputed vendor, keep in mind also that they are doing all they can protect your data. Now, there is a school of thought that says, in fact, that vendors will be going to above and beyond to ensure that your data is secure. This simple matter of doing the business. If the word gets out that they don't protect the data they house, then no one will want to do business with them. Ultimately, while we like to think that they are doing their best simply might not be good enough. There are a lot of ways that their cloud and your data can be compromised. First, with the hackers. Hackers aren't the nice people that Hollywood has made them out to be. Most aren't just sitting around drinking Mountain Dew and trying to break into the secure network just because they can. They want something. Yes, there is a lot that they can do. They have compromised your data. So they need some money for your data. Next is the bot attackers. In a commonly recognized worst case sensitive attackers uses the botnets to perform a distributed denial of service attacks. In order to get the hackers to stop attacking on your network, you face the blackmail. Thank you. That we are going to see in today's session. First, we'll look at the definition of the SaaS. Then we'll see SaaS is everywhere. Third, we'll look at the business perspectives of the SaaS. Then we'll look at the advantages of the SaaS. And at the end, we'll see the multi-tenant nature of the SaaS solution. So let's get started. Starting from the definition of the SaaS. What do you mean by this SaaS? So this SaaS is software as a service. It is also known as on-demand software. So it is a software delivery model in which the software and its associated data are hosted centrally and accessed using a thin client, usually a web browser over the internet. We have seen the thin client. So what it has a monitor, it has a keyboard, mouse, and it has a internet connectivity. And through the browser, we can connect to the softwares which are not installed at our location, but that are at some remote location. Simply putting, this SaaS is a method for delivering the software that provides remote access to the software as a web-based service. The software service can be purchased with a monthly fee and pay-as-you-go model. The pricing model is pay-as-you-go. So whatever the amount of software you use, that for that time only you have to pay. Now understand the next concept, that is SaaS is everywhere. If you look around the web, we can see the SaaS is everywhere. Here you can see, if you open the YouTube, if you open the Gmail, if you open the Facebook, if you open the Amazon.com, if you open the eBay, all these websites are nothing but a software as a service. They are all located on a cloud. Next, we'll look at the business perspective. This software as a service has a lot to appeal to the businesses. Why? So there are a few reasons for it. First is the multi-tenant software architecture. We'll understand this multi-tenant architecture in the future slides. Second reason is it has the lower cost. Investment is fast, and the users are using the shared licenses. Next reason is it is highly manageable. That is a high manageability. The clients can manage the softwares from their end. When we purchase this SaaS service, the deployment of the software is free. And whatever the support required for the software is also free. That means it is a free of deployment and the support. Next reason is its cost effectiveness. As we know, we are using here pay as we go pricing model. The next reason is customization of these softwares are easy. And we can scale these softwares well. We can scale it for the commercialization purpose. Next, look at the advantages of the SaaS. First advantage is it is easy to use. Most SaaS applications do not require more than a web browser to run. It's cheap. The pay-as-you-go pricing model of the SaaS makes it affordable to small businesses and individuals. Third is the scalability. The SaaS applications can be easily scaled up or down to meet the customer demand. Consumers do not need to worry about the additional computing infrastructure to scale up. That is being taken care by the cloud service provider. Compared to the traditional applications, these SaaS applications are less clunky. They do not require the users to install or uninstall the binary code on their machines. Advantages continue. The applications are less prone to the data loss since the data is being stored in the cloud. If you have the local storage with us, it can be damaged, it can be stolen, and it can be lost. So we can lose our data, but here is not the case. The data is always available as it is stored on the cloud. Due to the delivery nature of the SaaS through the internet, the SaaS applications are able to run on the wide variety of the devices. We can run on the mobile phones, PDAs, laptops, or desktop machines. Yes, so large variety of machines we can run the SaaS application. It allows for the better collaboration between the teams since the data is stored in a central location. Next advantage is the velocity of the change in the SaaS application is much faster. That we call as the SaaS favors agile development lifecycle. What about agile development lifecycle? We know when we are using the software, there are frequent changes into the software, and these are on demand. To meet the customer requirements on time, the agile development lifecycle is being used, and the SaaS favors this agile development fast lifecycle. In that, a quick implementation of the software is being performed. The updations are done on the regular basis. So most SaaS services are updated about every 2 weeks, and the users are most time unaware of these changes. That we call as SaaS, that we call as agile development lifecycle. And next advantage is it eliminates the need for the application administrator. So these are the many advantages of the SaaS solutions. Next, we'll look at the multi-tenant nature of the SaaS solution. What do a multi-tenant? Before understanding the multi-tenant concept, we'll look at the single tenant architecture. In the diagram, you can see here, there are two clients shown, client A and client B. Now, the client A wants to access to his database, and client B wants to access his own database. That's the client B database. Now, in the single tenant architecture, we can see the software platform used for accessing this client has a different. The instance for this client A is different, while as client B is using the another application, client B application. So here, the client A and client B are using their own applications or the separate applications for accessing the database. Now look at the multi-tenant architecture. Here, there are three users shown, client A, client B, and client C. They have their own database or they may share their databases. And now they want to access their database. So should I create the three different systems for the each user? Or if I use a single application, common application for the all clients, that will be easier. If we are using a single application for all the clients, and through that application, they may get to access to their own databases, such type of architecture, we call it as a multi-tenant architecture. So that is a special feature of this SaaS solution. So in this way, we have learned the basics of the SaaS solution. I hope you enjoyed this video. Thank you. Look at the content that we are going to see in today's session. First, we'll look at the definition of the PaaS. Then we'll see the features of the internal traditional development environment and the PaaS. Then we'll see the various categories of the PaaS solution. We'll list down the various advantages of the PaaS, and we will understand the disadvantages of the PaaS. So let's get started. Starting with the definition of the PaaS. What is the PaaS? So this PaaS, that is a platform as a service, is a cloud service where the customer gets the set of the application and the product development tool hosted on the provider's infrastructure. Here the consumer does not have the control and own or manage the underlying cloud infrastructure, including servers, OS, storage, security devices, network, but has the control over the deployed applications and possibly also the configurations of the hosting environment. This PaaS solution provides a collection of the hardware and the software resources that developers can use to build and deploy the applications within the cloud. Depending on their needs, developers may use the Windows-based PaaS solution or a Linux-based PaaS solution. Using the PaaS, developers eliminate the need to buy and maintain the hardware, as well as the need to install and manage operating system and the database software, because the computing resources no longer reside in the data center, but rather in the cloud. The resources can scale up or scale down based on the application demand, and the company can pay for only those resources it consumes. Further, because the PaaS eliminates the developers' need to worry about the servers, they can more quickly deploy their web-based solutions. In the next session, we'll see the features of internal traditional development environment and the PaaS solution. So we'll compare it on some of the features. So we have the three columns here. One says the feature, another says the in-house development application, and third column says about the PaaS for the application development. We will talk about the first feature, that is the multi-tenancy. We understood in the previous session the nature of the multi-tenancy, the meaning of the multi-tenancy. So in-house application development, it is intended for a single or a small group of users. The platform that is provided here is intended for a single or small group of users. But if you look at the PaaS solution, as it supports the multi-tenancy, it has a multi-tenancy nature. It supports hundreds to thousands of the users, each with the multiple active projects. Partition of the data is a must to protect the several users. As if we are having the thousands of the users using the same platform, there should be a separation between their data. That is the partition between their data. Next feature, we'll discuss about the user endpoints. In the in-house application development model, the application-based tools and browsers are being used. Whereas in the PaaS for the application development, we are using the web browser-based tools. Third feature we'll compare is deployment. The deployment and the scalability are left for the installation and go live phases in in-house application development. Whereas in PaaS for application development, the scalability, failover, and load balancing are the basic building blocks. Next feature is the runtime monitoring. For the in-house application development, the development solutions are usually not associated with runtime monitoring. Whereas in PaaS for the application development, built-in monitoring available with the development platform. Next feature is the virtual machines, servers, storage, and database. In-house application development, we have the multiple options available and can be customized to meet any user requirement. Whereas in PaaS for the application development, need to work with the infrastructure offered by the PaaS. We cannot change it. Next feature is the IDE. For the in-house application development, we may have separate environment and infrastructure for the development, test, debugging, and production. Whereas in case of the PaaS for the application development, we have the same environment for all the phases. So this is how we can see there is a difference between the in-house application development and the PaaS for the application development. Now understand the categories of the PaaS. Basically, there are 4 categories of the PaaS. Category 1, 2, 3, and 4. Now we'll understand what the category 1, 2, 3, and 4 means. The category 1 means the software vendors can use the current tools which they prefer to locally develop the software. Once they compile and raise the application, they can upload it on the cloud. What are the examples of this category 1? Are the Force.com, Google Jump, Long Jump, Magic Software, Microsoft NetSuite, TIBCO, and WaveMaker. What is the category 2? The PaaS vendors in the category 2 provide a cloud-based development environment, which includes stages such as design, coding, debugging, testing, staging, and deployment. All phases provide the browser-based access. The developers build and test application at the PaaS provider site. What are the examples? Are the Force.com, Intuit, Trackvia, and Wolf Framework. Now, category 3. Category 3 are these PaaS vendors target the business experts, not coders or developers. The vendors provide the tools, templates that can be easily customized to build the application. Examples of this are Caspio, Cordis, Mendix, WorkExpress, Zoho. And last is the fourth category. In this, the PaaS vendors enable the developers to use the tools for building the applications either locally or in the cloud. The developers can use the cloud to stage, deploy, scale, and manage the applications. The examples of the category 4 are Amazon, CloudBees, Engineered, Gigaspaces, IBM, Giant, Microsoft, Red Hat, Standing Cloud, and the Cloud Foundry, VMware. So these are the 4 categories of the PaaS solution. Moving towards the advantages of the PaaS, it has the various advantages. First is the ubiquitous access to the resources and quick deployment. Second, it provides an integrated development environment. Third, it has a lower total cost of ownership as we don't purchase any type of hardware. We just rent, take it on the rent. It lowers the administrative overhead. We don't have any type of hardware, servers, storages at our end. So it lowers the administrative overhead. More current system softwares, the updated software patches are automatically installed on the at the cloud provider's end, and that are immediately available to the clients. Increase the business and IT alignment. And next is the scalable solutions. We can increase the resources as per our demand, or we can lower the number of resources as per our requirement. Like the advantages, there are some disadvantages of the PaaS as well. What are those? First is the lack of visibility. We can't see the hardware at our end, so we have the less visibility to the actual hardware. The portability or interoperability with the applications on other cloud. It is not easy to make it portable to switch from the one cloud to the another cloud. Third disadvantage is concerns about the data security because we are providing our hardware into the cloud provider's hand. Next disadvantage is the risk of the breach by the PaaS provider. When you give your data into the other's hand, there is always a risk. That same case applies with the PaaS provider. So what we have learned? So we have learned the meaning of the PaaS. We understood the features of the internal traditional development environments and the PaaS. We learned the various categories of the PaaS, and we have listed the various advantages and disadvantages of the PaaS solution. I hope you enjoyed the video. Thank you all. What are the co-located data centers? We'll understand the concept of load balancing. Then we'll see what is the system and storage redundancy. And we'll see the advantages of this infrastructure as a service solution. And at the last, we'll see what are the IaaS server types. So at the end of this lecture, you will be understanding the detailed IaaS service. So let's get started. Starting with the definition. We'll define the infrastructure as a service. Infrastructure as a service is a model in which you, as a customer, pay for the resources, such as power, memory, storage, bandwidth, security devices, load balancer, etc. And these resources are kept at the provider's facility or wherever the provider keeps its hardware. In this IaaS, the provider owns the equipment and maintains it at the level specified in the previously agreed upon service level agreement. So many companies that deploy the applications to the cloud will need a specific platform, such as .NET, such as the Windows, .NET, Microsoft SQL Server, or Linux, Perl, and MySQL. Utilizing the platform as a service solution eliminates the company's need to administer the operating system and the supporting software. The other companies, because of the security needs or the desire to manage all the resources, turn to the infrastructure as a service providers. An IaaS provider makes all the computing hardware resources available The customers in turn are responsible for installing and managing the systems, which they can normally do over the internet. So this is how we can look at the infrastructure as a service. You can see your enterprise and the users and the physical servers, the storages are at the cloud. They are at the cloud means they are positioned at some location. That location we call as a data center. And that is owned by the cloud service provider. The clients are only using it over the internet. That is the infrastructure as a service. Now, before we have understood the two services offered by the cloud computing is the SaaS and the PaaS. The software as a service and the platform as a service. Now we are looking at the third service, that is the IaaS, which is the base of all the two services. So on the top of the IaaS, this PaaS and SaaS resides. This IaaS has the virtual data centers, cloud centers, or we can call it as the data centers. So what is the data center? In the basics of the cloud computing, we have seen how the data center looks like. So data center have the storage devices as well as the number of servers. It has a stack of servers. So what it should provide? It should provide the access to the high-speed and redundant internet service. That data center, as it has the many servers at one place, we need the sufficient air conditioning to eliminate the heat generated by the servers and the disk storage devices. There are thousands and thousands of servers are there. As well, we need the conditioned power with the potential for the uninterrupted power supply in the short term and long term through the use of on-site diesel power generation. Power is required, so uninterrupted power service is required here. As well as we need the fire separation systems in case of any fire disaster. And lastly, we need the administrative staffing to support the hardware, networking, and the operating systems. So this is what the data centers must provide. Now understand the next concept of the co-located data center. To reduce the risk of the single point of failure, companies often create a duplicate data center at a remote location. That we call as a co-located data center. And should one of the data center fail, the other can immediately take over the operation. Unfortunately, the other data center will increase the company's cost, essentially doubling them because there are duplicate servers, network equipments, and the internet access and the staffing. So this is the diagram of representing the co-located data center. So this is say data center 1 and data center 2. The data center 2 we can say is a replica of the data center 1. That is a co-located data center. Their locations are at a different place. In case of any disaster, the data center 2 will take place the data center 1. Whatever the data, whatever the servers present in the data center 1 are present in the data center 2 as a replica. So whenever this goes down, we can directly switch over to the data center 2 so that a continuous service can be provided to the clients. Now we'll understand the concept of the load balancing. So across the web sites experience a wide range of the network traffic requirements. Sites such as Google, Yahoo, Amazon, and Microsoft experience billions of user hits per day. To handle such web requests, the sites use the technique known as a load balancing to share the request across the multiple servers. Understand it by the diagram. So we have, say, for the diagram purpose, we have shown the 4 clients here, but there can be thousands and lakhs of the servers clients are there. And say we have the servers 1, 2, and 3. If we have a single server and we have the thousands and lakhs of the queries at a single server, one server may fail to respond to the all clients. It may hang. So what we'll do, we'll balance the load. We'll increase the number of servers and we'll balance the load on the multiple servers. So these 3 servers are identical and the number of requests are being distributed among the number of servers. So here you can say the request number 1 and 3 is given to the server number 1. Request number 2 is given to the server number 4 and request 4 is given to the server number 3. So here we can balance the load. Next concept is load balancing and the replicated databases. Load balanced system for the data redundancy often replicate the databases on multiple servers. If you are duplicating this data center, that means we need to duplicate the databases as well. So here you can see in the diagram, each database here in turn will send the data updates to the other. This is the main server, database server 1, and it continuously sends the data updates to the database server number 2. So that there is a replica of this database. That is a replicated database. And we have a synchronization between the servers. So in case of the failure of the one database server, it may be switched to the another database server, which serves the need of the customer. Likewise, we should have the system and the storage redundancy. We have seen the concept of the load balancer, in which what we are doing, we are replicating the servers, we are replicating the databases, we are replicating the storages as well. Because in case of failure, we need the copy of the data at some another location. We understood the co-located data center as well. So here you can see the load balancer is being shown, and these are the number of clients. And this is an example of the AWS cloud. Here is the EC2 instance, that is a cloud compute cloud. So here we have the number of instances, and the load is being balanced among the multiple instances. This cross shows this instance is not working. So we have the replica of those servers at the another 2 instances, which can serve the need of this server, because both 2 servers have the same data. This is the example of the storage redundancy. This is the system redundancy, and this is the storage redundancy. We can keep the storage at the multiple sites. So this you can see, this is the primary site, and this is the replication of the data at the replica site. So this is an example of the Amazon S3. S3 is the storage service provided by the Amazon, where we can put our data in the buckets, and we can make the replica of the bucket. So in case of the failure, the service is being transferring your link to the replicated site. Now we'll understand what is the NAS. NAS is network attached storage. So these are the devices present in the cloud-based storage as mountable devices, which may be replicated in the cloud to meet the company's data redundancy needs. So this is how the NAS devices are being attached in between. This is your storage. This is a mounted cloud-based storage device, and this is a network device, network storage device. That's what is the NAS. It keeps the copy of the data which is available on this storage device. It keeps the redundancy. Then we'll understand the cloud-based data replication. So using the cloud-based NAS devices and the cloud-based databases, companies can replicate the key data within the cloud. That is possible with the help of the co-located data center as well. So all these things helps the replication of the storage, replication of the database, replication of the system. All these things will make the replicas. Understand the advantages of the IaaS. First advantage is elimination of the expensive and the staff-intensive data center. There is no need to maintain the data center at our end. All the hardware is being kept at the cloud provider's end. We don't have to administer it. Ease of the hardware scalability. This IaaS provides a scale in and scale out for facility, so that it is easy for the hardware scalability. It reduces the organization's hardware cost because we don't have to buy it. We can use the hardware or infrastructure on demand and pay as you go scalability model. As we don't have the hardware at our end, we can reduce our IT staff. There is suitability of the ad hoc test environments with the help of this IaaS. It allows the complete system administration and the management. Now we'll see the IaaS server types. There are basically 3 server types. First server type is a physical server. Physical servers are the actual hardware is allocated for the customer's dedicated use. Dedicated virtual servers are the customer is allocated a virtual server which runs on the physical server that may or may not have the other virtual servers. And third type of server is a shared virtual server. Here, the customer can access the virtual server on a device that may be shared with the other customers. So these are the 3 server types. Within the IaaS environment, the customer can allocate the various server types. So this is the diagram shows the physical server, dedicated server, and the shared virtual server. So what we have learned in the today's session, we defined the IaaS. Then we have understood what the data centers must provide. What do we mean by the co-located data centers? We understood the concept of the load balancing and the replicated databases. We understood the concept of the system and the storage redundancy. We understood the NAS and the cloud-based data replication, and we have listed the IaaS advantages and the IaaS server type. I hope you enjoyed this video. Thank you.